Okay, I'm on section 6.1. No, I'm not. I'm on 6.4, and I'm on example 1. And it says solve each equation algebraically over the domain for the unit circle, so it's from 0 to 2 pi. Okay, so we might want to have our unit circle handy again. When we look at A, we have cos 2x plus 1 minus cos x equals 0. Okay, can we simplify this in any way? And when I mean simplify, I mean probably make it more complicated before we can simplify it. What about that cos 2x? Is there any of those double angle ones that just have cos in it? Because we probably don't want to bring a sign into this. It'll probably make it confusing. 2 cos squared. Okay, so I'll put x's because I'm using x minus 1. And so all I did was I replaced my cos 2x with that, this whole thing. And then I still have plus 1 minus cos x equals 0. Okay? So I took cos 2x and I replaced it with this 2 cos squared x minus 1 from my identities. Okay, I don't really need this bracket here. I just was putting it there to show what I replaced. Okay, so if we get rid of the bracket, okay, this is what we have. So we have a minus 1 plus a 1. So those are 0. And now we have a 2 cos squared x minus a cos x equals 0. Okay, so what's common to those both? They all have a cos x. So let's divide out by what's common and put it out front. So I would put cos x out front, and then I'm left with a 2 cos x here, and a cos divided by a cos is a 1, and there was a minus there, so it's a minus 1 equals 0. Okay, so now we can split this into two equations. We can say cos x equals 0 and 2 cos x minus 1 equals 0. And then we can solve to see what cos is. Okay, so in here, cos x is equal to 0. So on your unit circle, where is cos 0? Okay, at half a pi and 3 pi over 2. Okay, and then if we solve to find out what cos is here, I'll add 1 over. So I get 2 cos x equals 1, and I'll divide by 2, and I'll get cos x is equal to a half. So where is cos a half on our unit circle? And where else? Okay, so those would be our solutions. Example 1b is 1 cos squared x is equal to 3 sine x minus 2. Okay, so we need to simplify this in some way. Okay, so whenever I see this, I'm thinking we either got to get rid of the cos or we got to get rid of the sine, because we probably want one or the other, right? What's this guy? He can be sine what? Squared, right? 1 minus cos squared can be sine squared. Because of that Pythagorean identity, sine squared plus cos squared equals 1. So if you subtracted the cos squared over, 1 minus cos squared is equal to sine squared. Okay, so if we get everybody on one side, so let's move everybody over to this side. So we will have sine squared x minus sine x plus 2 equals 0. Here we go. There's a 3. Okay, so if we can't look past the signs, it might be confusing. What if for a moment here we thought of the signs as just like squareds, like x squareds or something? Okay, so what if we replaced sign with x? Okay, so then this would be x squared. Don't worry about this. Minus 3x plus 2. Okay, does that look less scary? Yeah, it's trinomial, so you say what's a multiple of 2 that adds to minus 3? And it's negative 2 and negative 1. And so we can just put the signs back in. Okay, so we only replaced it so that it was something that we could actually understand. Okay, so we remember that still equals 0. So now we have two separate equations. You split them up and you write sine minus 2 is equal to 0 or sine minus 1 is equal to 0, and you can solve. So you add 2 over. Sine is equal to 2. Add 1 over. Sine is equal to 1. Okay, sine is equal to 2 does not fall on our unit circle, right? Our area was from 0 to 2 pi, right? This does not show up, so that's no solution there. Okay, and then sine equals 1 is what on our unit circle? 90 degrees or half a pi. So then that should be our solution. Example 2 on page 318 says, solve the equation cos squared x equals cotangent x sine x algebraically in the domain of 0 to 360. So the last ones we were talking in radians, this ones we're just talking in degrees. So our answers will be in degrees. Okay, so we probably want to simplify this equation. Okay, so who sees something there that's ugly that we could maybe fix? Cotangent, yep. Okay, so what could we replace him with? Cos over sine? Put the x's with him. And then we still have this sine multiplying to it, right? Okay, so then we're going to cross off the signs because there's one in the top, one in the bottom. And we end up with cos squared x is equal to cos x. So if we move everybody onto one side, so let's subtract this cos x over, we get cos squared x minus cos x equals 0. So now what could we do? Yeah, divide by cos x, divide by cos x, and we're left with cos x that we divided out on the outside, and we have a cos x minus 1 on the inside. Okay, so now we just have two pieces. So we have cos x equals 0, and then we have cos x minus 1 equals 0. So if we add the 1 over, cos x equals 1. Okay, so where is cos equal to 0? And we're talking degrees. 90 and 270. And where is cos equal to 1? Zero degrees? Okay, so those are our solutions.